Okay, I
Great.
guess.
Now you can start the event, Mr. Clark.
Uh, all right, I started. It says we're
All
ready.
right. Great. So, first, I would like to welcome all of you today to our April webinar that is hosted by Fiber to the Home Council MENA. Our welcome extends to our members and their partners, and we hope all of you join us, if not in the council, and you enjoy the benefits from today's webinar. I would like to thank our council member Dura-Line as well in accepting our invitation to this initiative and leading the way with three of special matter experts speaking during these webinars. But with today's webinar is about creating order out of chaos in your data center by Mr. Clark Guller. Mr. Clark is Dura-Line's major account manager in the US, has worked for 10 years at Dura-Line. Mr. Clark brings vast experience of Dura-Line's microtechnology products with a keen specialization to developing solutions for large hyperscalers and data centers. Prior to Dura-Line, he was a sales representative at Pacman, beginning his career selling technical polymer and biocide solutions to the pulp and paper industry. Mr. Clark has been active in a number of trade organizations and is a current volunteer on the BICSIOSP Standards Committee, the Building Industry Consulting Service International, outside the plant designer, and he holds a bachelor's in business administration from the University of San Diego. Mr. Clark, I'm very happy to welcome you today, and I will step aside to give you the full floor. For all the attendees, please, for the questions and answers, we will start and give like 10 to 15 minutes once Mr. Clark finishes the presentation. Thanks again, Mr. Clark, and welcome.
Well, thank you. All right, let's get going here this morning. So again, my name's Clark Guler. I live here actually in Boise, Idaho, here in the United States, and I've been working in the data center space, whether it's with large hyperscalers or colo data centers. So with that, we'll just dive into the presentation. So this is just a generic map that I like to show people. I don't know how detailed it is on your screen, but these are all the various applications where Dura-Line makes conduits. So we play in like the high-rise MDU space. We play in like cable and conduit. We play in like fiber applications. And so if you're not familiar with Dura-Line at all, but we've been in the pipe industry a long time, starting out in 1971. And really started out in the water and gas pipe industry. Then, since in the early 80s, been in telecommunications industry. So a strong history of innovation, whether it's, products that have built-in locate wires or multi-cell products or products for micro trenching. So if you're not familiar with Dura-Line, maybe get on our website and learn more. So some key facts about Dura-Line: global manufacturer, of course, is really important. Nearly about 2,000 employees, 21 manufacturing sites around the world. And I love this statistic on the bottom right there. It's a couple years old, but it'd be even more today, where we made 430 million meters of pipe in 1 year. So it's over a billion feet for the way, I think I don't think in metric, but a lot of pipe that's made in our facilities. So we're definitely in the industry. Here's a map of some of the plants around the world. So you can see several plants in Europe and in India as well, and 11 in the US. So this is kind of just a rough overview of the products. So on the far left, we have standard products. The section on the right is on micro products, and we'll dive into those quite a bit today, as well as in the next column over is a lot of the cable and conduit, whether that's for like an MSO or a power company, and then of course all the accessories. So I understand when we talk about data centers that it's actually a pretty broad term. So it could be just like a small enterprise data center, right? Some set of just a small closet maybe, or a small room that you have at your corporate office. It could be a managed data server, something, across town that maybe you operate in. It could be what's considered like a co-location or a colo data center. And it could be more of like one of the large cloud type data centers. So we talk about data centers, it could mean a lot of different things to you. And so I recognize that, and we're just going to do our best to provide some ideas and solutions for probably mostly focused on the colos and the large cloud data centers, to be honest. Not so much the small enterprise data centers that somebody might have in the basement of their building. So here's like a really rough map of a data center campus, right? So I've got multiple buildings, and maybe I've got some conduit runs between the buildings, and then I've also got some runs inside the buildings. So this presentation is actually really nice because we'll talk about some solutions out in the like between the buildings or maybe around the buildings in the security area or the fibers feeding into the data centers, as well as we'll focus on some solutions that talk about duct inside the walls. So first we'll focus on the outside plant, what I consider outside plant material, maybe around the data center or between the data center buildings. And then later on we'll focus on solutions inside the data center walls. All right, so lots of different options here of ways to deploy things, but I've got a few pictures from some installations that I've been on over the years. And so the picture on the left, of course, is a 6912. That's currently the largest fiber cable in the market, at least I'm familiar with. I know many of the manufacturers are working on fiber counts greater than 10,000 strands. But it's not uncommon that I see these large 2-inch duct banks being built. So that's the picture on the right where you see all the, I think it looks like 24 2-inch conduits. They're all striped and colored coming in, and this allows the hyperscale ability to deploy up to obviously a 6912 on those. Oftentimes we do see the 3456s or 1728s deployed, but this concept of having one cable inside one duct is, I would say, growing here in the United States, as opposed to having a larger conduit with multiple cables in there. So just a couple pictures of, like I said, some maybe the extreme example of some really high count cables feeding between the buildings. So again, these are large count cables. You can, for the most part, they're above 1728s. And all the cable manufacturers continue to kind of invest in this area. I see them coming out with larger fiber counts and smaller diameters. And so that allows us to do a couple things, but one is it allows us to use smaller size conduits so we can get more fiber density in a given area, but it also is changing the way that I'm seeing the hyperscalers deploy the fiber cable, because they're being able to blow and jet in the fiber cable versus pull in the cable. So inside some of that duct, maybe you noticed it, it's called, it has a white lining, and that's a product that Dura-Line calls Silicor. It's a permanent super slick lining. And I think this is really important when you get into the data center market, because the cost of the cables and the risk that's involved with installing these high count cables is so great. So the Silicor lining lowers the coefficient of friction, or what's called the COF. And we can measure what this coefficient of friction is. So inside of these conduits, and I would recommend it if you're building a large fiber network yourself, is to use the Silicor lining from Dura-Line, because it's going to put less stress on your fiber optic cable during installation, and you're going to be able to pull it in further. You're going to be able to jet it in further because of that. So just kind of moving along here, one of these construction methods that maybe you're familiar with, that you've seen, and that's actually a really common, what I would call like a true fiber to the home application. And I know, I'm thankful to be doing the presentation from the Fiber to the Home Council here, but it's a construction method called an override. And what it is, and this is just one example of it. So I've got a picture of a 2-inch conduit with a cable inside, and I want to utilize this existing architecture inside of this existing conduit to deploy a new fiber optic cable. So this is also very viable for data center type customers that have existing conduit in the ground. They have a cable in there, but they really have some existing space that they could utilize. So I apologize on this slide because I had uploaded the presentation and I'm not necessarily doing a screen share through PowerPoint, so it doesn't show you all my animations. But essentially what it's showing you is the first thing that we always need to know on the left is what's the size of the duct we're working on, right? So customers come to us all the time and they're like, hey, will this fit? Will this work? And of course, I've got a variety of questions to ask them, but I always need to know what size of conduit you're working in, what's the existing size cable, right? And then we can figure out how much space we have. And then through a dialogue, you might say, I'd really like to get another, whatever it might be, right? 288 count, 432, an 864 between building A and building B, and how can I do that? Or I need to get another fiber feeding into my building. And so doing an override is really advantageous because, of course, we don't have to dig in the ground. We're just going to utilize this existing architecture. So moving along. So then we start talking about a product called FuturePath that I'm seeing deployed inside data centers as well. And we'll get to that. So FuturePath is actually a trade name for Dura-Line, and all they are bundled microducts. And why they're popular is you can get much higher fiber density than you can conventionally. So we'll get to, some more slides on the fiber cable. But essentially, we're going to use microducts, which require the use of micro cables. So all the major fiber manufacturers make what are called micro cables that are made to be blown and jetted versus pulled in. And because of that, they can shrink down the form factor of these fiber cables because they have less, jacketing material. The center strength member is much smaller. A lot of times they've shrunken down the size of the buffer tubes, things like that, so we can get much more fiber density. And then really the main change, a lot of it is because these cables are made to be blown and jetted and not pulled in. We're going to install them at 200 to 300 feet per minute using the use of a jetting machine. So the ability to install a lot of cable very easily and quickly is also highly advantageous. And what's changing, I've got a couple slides on it coming up, are the fiber manufacturers continue to develop some really high count cables that really come to play in the data center space. So I'll show you some slides of some 864 count micro cables coming up, and of course we've got some future paths that accommodate that. So again, just kind of moving along. So it's not uncommon to have these, large duct banks between buildings, right? And the vaults on a data center campus, especially the large hyperscalers, are enormous, right? They're sizes of like small rooms, as I would describe. And you can see the picture on the left of the vault where you've got, it looks like, 18 or 4-inch conduits on the bottom and another, 10 on the top. So it's not uncommon to see, 30 to 44-inch PVC conduits running into these large vault systems. So I would like, to show you some methods that I see people utilizing this existing architecture that they already have. So one of the things when I was talking about pulling in these high count cables is I understand that sometimes customers really need these high strands day one, right? They are going to put in a 3456 and basically light up all 3456 strands. But a lot of times the customer's not. They just try to put in the largest cable that they can kind of fit into the duct because they're trying to future-proof their network by putting a lot of dark fiber in there. And I'm seeing a little shift away from this because I've listed my bullet points. I call it takes like a small army to install these cables. So maybe you've seen this or not, but there'll be like 20 or 30 guys out on these job sites installing these cables because they're very large and heavy, and they're very expensive. And I call them like a white glove installation. So you've got all these guys kind of pulling these cables, figurating them vault to vault, making sure that they don't overbend the fiber optic cable, because the cables, have certain bend radiuses based on their diameter. And some of these reels are very expensive. It's you know a reel of 6912, and I know not everyone's deploying that, but it cost over like $500,000. So there's just a lot of risk when you're moving this around with the forklift and handling this. So customers are looking for ways to like mitigate that risk. I'd mentioned that they, don't necessarily light up all the strands, and so having a place to land all the fiber cable, all the connectivity, it costs a lot of money to test and terminate all this cable, and of course the splice management, splice cases and just managing that many strands of cable can be really difficult. So I'll show you some solutions kind of against that. So I've seen several customers here in the US take this existing conduit that you might have, like a 4-inch PVC, and populate it with multiple microducts. And what this allows you to do is to segment it so that you can deploy a micro cable incrementally. So in this example, and there's lots of different things that we could populate it with, we've got 8 22 by 18 millimeter microducts, and then inside each one of those microducts, we can put in an 864 micro cable. So on the picture at the bottom right there, it's kind of small, but it's a 864 micro cable. It's a ribbon cable. Multiple manufacturers are making these 864 micro cables now. And you can see how we could put, 8 times 864, so 8,600 strands of cable, which is real competitive to, say, installing 3 3456s, something like that. And again, we're doing it in a much safer manner. We're able to do it incrementally, so it's much more scalable as well. And it also just prevents a lot of damage happening to these cables because we're going to be blowing and jetting them in, not pulling them in. So I just got some pictures of that. So a lot of times customers have a hard time visualizing what I'm talking about. So I've got these large duct banks here. You can see these big vaults, and the contractor in this case is just pulled in the individual microducts, vault to vault. And they've done this work in segments. And then in the vaults, they can couple them together using these airtight, watertight couplers. Once we install the duct segment to segment in sections, that now allows us to install the cable end to end so that we don't have to have a splice point in our fiber cable. So when you come into the vaults, maybe you're coming in from the north side and you need to exit to the east or the west, you can easily route and bend the microducts inside of the vault. And so again, I've just kind of got a few pictures of, you can see the individual microducts being routed around. All right, kind of moving along. So we did populating it, if you look at my slide here, populating an existing 4-inch, we looked at an override. Now we're just going to continue along to, kind of more of, I'm going to call it an old school method, where maybe I have an existing 4-inch conduit, and now I'm going to either maybe pull in 3 interducts, right? 3 1/4 or something like that is, been done for years, pretty traditional, but again, kind of an old school method where we're just going to populate an existing conduit and just give ourselves 3 pathways. So I want to show you maybe a new product to you that you haven't seen. We've had it here in the US for the last couple of years, and it's become incredibly popular, and we call them hybrid products. And what they are is they have standard sized conduits, like in this case an 1 1/4 or an 1.5 conduit, as well as microducts, all oversheathed together. And the advantage is that scenario where I said, hey, maybe I do need like a 3456 tied between my buildings day one, but I'd also like the ability to have some microducts. So it's kind of the best of both worlds. I've got some conventional size conduit so that I can put some high count cables as well as some microducts and stuff for future expansion. And the products themselves are actually are right around the same size as a 4-inch PVC. So we've seen some customers get away from this, building these large PVC duct banks and looking at installing just a lot of 6-way, say, hybrid future path products. So again, just kind of some visuals for you, and just trying to grasp the size of the products and what they look like and why customers are using them. So here's a couple of other scenarios that we see that are pretty common, right? So we started out talking about putting in just a bunch of like 2-inch conduits. And that is becoming more popular, of course, like in a greenfield if you're building something new, because the ability to have one cable and a duct is advantageous for pulling something in and out and jetting distances. Sometimes we're just working with the existing network, existing architecture in the ground. So then we talked about kind of an old school method where I've got a 4-inch PVC populating with some interducts, and then of course looking at like a 6-way hybrid product. So when I talk about the 6-way hybrids, there's actually several versions of them. There's 6 versions of them, at least here in the U.S. So I've highlighted 2 of them. The first one I've highlighted says it fits inside of a 4-inch PVC. So what this product has allowed us to do is use this existing network in the ground and fill up as much conduit as we basically can. So we're going to reduce the size of our 1.25-inch conduit to what we call like a true size conduit, and you can see the OD there is 3.35 inches. So we're going to get something that's 3.35 inches inside of a 4-inch. So it is pretty full, and I'll show you some pictures. But if you already have an existing duct bank run, we want to fill that up as much as we can with conduit, take the most use of it. And then the bottom one that I've highlighted is that 1.5-inch version, which is kind of gives you the highest density, where you've got 3 1.5-inch and then 3 microducts as well. So here's the kind of extreme example where I've got this 3 1.5-inch and then the 3 22/16. So you can see I can get nearly 13,000 strands in basically a size of a 4-inch conduit. So this is highly competitive to traditional methods. And again, it's a much safer method because we've got one cable per duct. So it's really common when I give a presentation, and a lot of times if we were face to face, I would actually have a piece of this pipe with me, right? And I would pull it out of my bag and I would show it to you. And so customers are like, is this stuff really flexible? How is this going to go on the ground? So I always like to just show some pictures. You can see the giant reel here on the left-hand side, and it being fed into a manhole situation. So the product's got enough flexibility that it can actually be bent into the manhole. And then you can see this customer is pulling in. This is that reduced diameter 6-way hybrid into an existing 4-inch run. So what's new? I've kind of been talking about them, and I keep up on this stuff real closely. I work with most all the major fiber manufacturers, but they continue to develop higher count cables that are smaller. So and there might even be more, but I know of 2 manufacturers that have 864 micro cables that are around the 12 to 13 millimeter range, and I believe we'll continue to see more. If you're really familiar with micro cables, there's been a lot of 432 micro cables on the market for years, to be honest, but they weren't ribbon. And so in the data center market, customers really want ribbon for obviously easy splicing. So now I'm seeing the development of ribbon 432 cables, and I need to probably update the slide because there's more than 2 manufacturers. I think there's about 4 or 5 right now that have 432 ribbon cables. And I'm seeing diameters down even around like the 9.5 millimeter range. And then, of course, I mentioned there's lots of manufacturers that are doing just what we would call like loose tube 432 micro cables. So be on the lookout if not familiar, but I've seen like 1728s go from basically like 1.5 inches in diameter now down to about 0.87, like less than 1 inch in diameter. So just continued, shrinkage of just the whole package. So again, the glass has really stayed the same for the most part. Most of the manufacturers are around 200 micron, somewhere at 250 and now gone to 200. But again, in just this picture here, you can just see the difference between these two 864s. The one on the right, obviously, is just got a thicker jacket. It's got the strength members in the jacket. It doesn't even have a center strength member. Where the one in the green microduct is actually an 864 as well. But again, this, it's more of like Kevlar strength in the jacket as opposed to fiberglass rods. Again, no center strength member, but it's all 200 micron ribbon glass. So now diving into the inside plant solutions, which is, we say data center, that's kind of where most people think that we're going to spend all of our time. So I apologize if you didn't benefit from learning a little bit about the outside plant construction that we're seeing take place in the data center market. So as we dive into the data center walls, we're of course going to be focused on riser and plenum rated materials because of the fire ratings. So again, kind of coming back to our map here, now we're going to dive inside the buildings. And again, apologies because I'm not streaming off of PowerPoint, but Dura-Line has a solution called EABF, and it's an acronym that just stands for Enterprise Air Blown Fiber. And there's 3 components to it. There are these EABF cables. So they're small cables that are made to be blown and jetted in. They're either riser or plenum. There's the pathway, right, the duct, and then there's the piece of jetting equipment. So this is a small handheld unit that we promote, made by Plumet or Plumatos, if you're familiar with them. So why do customers like this, and why do they do this inside the data center space? So these are obviously some buzzwords, some marketing words, and I'll dive deeper into why we see the use of conduit used inside data centers and the value proposition kind of around that. So it's scalable, right? So what do we mean by that? Obviously, it's a good buzzword. Install what's needed today. So it's very common that if a customer thinks that they need 48 strands between location A and B, they don't actually install 48 strands. They install 72, they install 96 strands. They future-proof their network by basically putting in dark fiber. And sometimes that's a really good way to do things, right? Because the incremental cost of putting in a 48 versus a 96 count is fairly low when you just look at the cost of the fiber cable, right? Because the cable manufacturers don't charge much more. However, it costs a lot more money to test and terminate and land all that cable into the connectivity that you might not be getting any revenue on. So when we install duct, if we actually need, because we've got a dedicated run, and I'll show you some slides that dive into this a little bit more so you can understand this value proposition, because I've got a dedicated run between point A and point B, if I need a 48 strand cable, I'm just going to jet in a 48 strand cable. And then in the future, if I happen to need more capacity, I can use my spare microduct, hook up my machine, and jet in a new cable in like less than an hour. And start my termination process, and then splice it, and then I can actually jet out my old 48 count cable, freeing up my spare microduct. So that's kind of what we mean by scalable. And again, kind of, when we talk about flexibility, we see customers that are maybe still doing some multi-mode or some single mode. This is more common like in the colo data center space where you've got different tenants that have different fiber needs and different counts. So the ability to maybe quickly install a single mode and then you want to upgrade. I apologize, maybe you're in multi-mode and then you want to upgrade to single mode. You can easily do that because we've got a dedicated pathway. We don't have to get back into the cable tray and worry about damaging all this live traffic with other customers that could cause risk. So again, the other buzzword is kind of, what we call smart. So we're only installing the fiber counts that we really need, and we don't have to guess, right? That's why I've got this 8 ball in the corner. I don't have to kind of guess what I want to do. The part that I have to plan on is how many pathways do I want going to each location so that I can figure out about how much fiber potentially I might want to deploy. So we'll dive into this a little bit deeper, but the a lot of the technology is not so much obviously in the conduit, but it's these small cables. So this is a small cable that's made by AFL, if you're familiar with AFL, or parent company would be Fujikura. And in the data center space, their market is through a company called AFL Hyperscale. And so Dura-Line actually sells this fiber optic cable as part of a solution. And these cables are incredible. So we offer from a 6-strand up to a 96 strand cable. So the 96 strand is 4.5 millimeters. So it's really small, and it allows us to go into a 6 millimeter ID duct. What's incredible about these cables is, of course, they're fully rated cables. So this idea of like airborne fiber has been on the market a long time, but a lot of the existing solutions weren't actually deploying true fiber cables. They were just like strands of glass in some kind of jacket, PEF type jacket, and they weren't considered cables. So these are fully rated cables. They meet Telcordia standards. The standard is called G409, but it's water block, it's Kevlar, it's jacketed. They're fully rated cables. No furcation tubing is needed at all. Again, they come plenum and riser, and they even come in some ribbon versions, or like the spiderweb ribbon or pliable ribbon, if you're familiar with those. So we offer these products. I see a question that was kind of on the right-hand side, in a variety of options. So they come riser rated, they can come plenum, or low smoke zero halogen. So there was a question I saw in the column, hey, do they come fire rated? Yes, they do, right? So basically 3 different fire rating versions depending on what you're working in. And we make some products that are just standard HDPE that maybe we would use between buildings, and then as we come into a building, we would transition to a fire rated material. We make some products that are armored as well. So this is kind of the rough breakdown. So we're going to use these smaller size microducts, which are 8.5 by 6 millimeters. So that's just the OD by the ID. And we offer quite a variety of configurations. So all the way from a single microduct through a 24-way. And you can see this 24-way is like just over, 2.13 inches. So it's really not very big at all. And if you put in the highest fiber count that we offer, obviously, this 96 count, you can get some really high fiber density. So, 2,300 strands in basically a 2-inch area is pretty incredible. And the ability to do this incrementally in a very flexible and scalable way is really powerful. So what does it look like, right? So we've got these multi-cell conduits. As we come into a building or within a building, we might need to transition from a riser space to a plenum space, or maybe it's from an outside plant building entrance where we had HDPE, again, to like riser. So we're going to just make this transition inside some kind of enclosure, so some kind of NEMA box. So you can see that we've just cut off the outer sheathing of the future path and exposed the individual microducts. And then we've coupled them together using these airtight, watertight couplers. And now I can continue to build my tube structure, so to speak, inside of my building, so that now I can blow and jet my cable as a home run because I've transitioned my fire ratings. So it's not uncommon that you can just see, I'm just going to show you just a few different ways to do it, where maybe I've ran 2 7-ways. You can see those like going north to south, but then I'm going to drop off some laterals. I'm going to drop off a couple of microducts in this given location, so I can easily bend and route the individual microducts so that I can jet my cable anywhere I want throughout the building. Lots of different products on the market. This is an enclosure where it's actually got, a splice case in it, a small cassette there, as well as some, future paths being routed and bent. So a lot of, basically different ways to deploy the network inside the building, whatever's kind of, best for you. So I'm, again, just kind of showing a few pictures. This is kind of the easiest, simple way. These are just some microduct organizers. So you can just see that orange kind of Dura-Line logo there in the back, and then you can see the individual microducts being held there, and then you can see the yellow riser cable coming out. So this is just a really easy way, like in an MDF or an IDF room, where you've got the fiber cable coming into the back of a panel, and we can just splice right into the back of it. So it's really common. Customers will ask, hey, I'd love to have some home run fiber rack to rack, but I've got 2 different buildings, right? So I've got to run this duct through a vault system, and how do I keep water and debris out of there? So there's some great, I'm going to call them enclosures on the market. This happens to be one that's made by 3M that works really well. So you can just see different future path combinations coming into this enclosure or this duct splice case, and they're coupled up together. And this is something that could be put in a manhole in a vault in the outside plant world. Just some more pictures of again, there's a lot of ways to do this, but just some microduct organizers inside of a large MDF. And what's nice about this is it's built modular. So you can see how we have 8 microducts across, but if we want to add more microducts to this given location, we can just add these little brackets that cost about $10 really easily, and just continue to build out however many ducts we want. And it's a really easy way to label them and identify them all so that we know what microduct is going where. So apologies on the video, because again, I uploaded it. So if you'd like to see a copy of the video, send me an email. My information is going to be at the end. I can send you the link. It's on Vimeo. But all I was going to show you is just what this looks like, right? So you can see the jetting unit. It's ran by a cordless drill. And then, of course, we're going to need some kind of air supply. So you can see that red there. Most typically, we see a bottle of nitrogen used. You can also see the yellow fiber optic cable. So all the operator is going to do is pull the drill. You're going to see the drive wheels turn, and the cable is going to start to jet in at about 150 or 200 feet per minute. As the cable gets further out there, and what do I mean by further? 100 to 200, 300 feet out there, it's going to slow up due to friction. So now it's our brain turns on, and we say, hey, I need to add some air. So now I'm going to open up the air block to insert this high pressure air down the microduct, basically flowing over top of the micro cable, and that's what's going to jet it in. It's how fast the air is moving over top of the cable that's going to carry this cable. So how far can I jet a cable? The rule of thumb for the 6 through 72 count is about up to 3,000 feet, which is one of these units in a tank of nitrogen. The 96 count, because it's a little higher fill ratio, it only goes about 2,000 feet. So that doesn't mean that that's our end all, right? We could set up in the middle of a run, jet one direction, figure eight our cable off, jet the other. We could jet and figure eight the cable and then move our setup. We could have lots of variations, but most buildings aren't longer than about 2,000 feet. So this ability to set up like in an MDF and jet our cable all throughout our data center from one location is highly advantageous. So again, talking about home run fiber, right? Because the cables are riser or plenum rated, whatever you need, we're going to install the cable end to end. We're not going to have splice points between an outside plant or an inside plant cable. So now we're going to focus on some real specific applications inside of a colo. So if you can see this, this diagram, it might be a little small, but essentially we've got, let's just say 1 or 2 meet rooms, right? So this is where the outside plant cables are coming into the data center. And then from there, we're going to need to transition to all of these customer suites or pods or cages. I mean, there's a lot of terms that are used. So what this allows us to do is we're going to install a future path product, all these individual microducts to these suites. And why colos like using future path in this application is because they have different tenants that are coming in and out of their building. And so the ability to install a cable very easily Obviously, we can jet the cable in like less than an hour, right? Like setting up the machine, jetting it in, doing that whole piece doesn't take very long. Obviously, then we need to do the splicing, but essentially, if it's a 48 or 72 count, one of the lower counts, they can get customers turned up in like a day or two, as opposed to having to get security permission to recable this entire area, and there's also a lot of risk. And so it's very common that it takes a week or more a lot of times to upgrade or add a new fiber cable or upgrade a customer that wants more strands. So just this ability, maybe a customer adds some new racks in there and they need some more fiber, we can very easily jet in a new cable to that location in a very safe manner. Again, it keeps things really organized, right? So in a colo, how do you know what cables are active and which ones aren't? And these people like left, and did we really tear out all their old stuff? So it also comes into like cable management, like organizing our ladder rack and our cable tray in a way that's lasting, as opposed to just keep throwing cables into the cable tray or the ladder rack until they collapse. Again, it also is advantageous because we're just deploying the fiber counts that we actually need for this customer. So if you have a customer that needs a couple 72 strands, we're just going to jet in a couple 72s. But maybe you've got a different tenant that just needs a couple like 148 strands. So we can just jet in 148 to that customer. And as their demand changes, we can just easily jet in higher count cables and actually jet out the old ones, freeing up that spare duct. So here's just some pictures of how we see duct routed inside colos. And of course, you can build redundant rings inside of these colos as well. So here's just a picture. Obviously, it's kind of an extreme example of all these individual microducts coming back to a room, and each microduct represents a home run to a given location. So again, pictures. I love pictures because obviously I sell the solution for a living, so I have a pretty good understanding of it. But if this is new to you, it's really hard to have a visual of like what this looks like. Or you see a 1 foot piece of pipe come out of somebody's sample bag, and you're like, is this going to bend? Is this really going to work? So just some pictures of, you can see both future path and individual microducts that are routed here in cable or some ladder rack. You can just see how they bend and route. So really nice installation where they've obviously got it Velcroed. It's real clean looking, but it's just a nice visual to see how duct can be routed and ran inside of a building. Here's some other good pictures, right, where we've got individual microducts as well as some future path. They've got some, some existing plenum and riser, but again, just seeing the bend radiuses. You can see the pictures on the far right of the duct coming into the back of the panel and the splicing that's taking place. So again, we've mentioned it, we're home running the cables end to end, rack to rack, depending on where we want to go. Again, just some more pictures where you can see the microduct coming in the back of the rack and the cable, coming, right here. So sometimes customers, what's hard about the data center space that I've learned is that everybody has like a non-disclosure agreement and nobody wants anybody to know what they're doing. So it's really hard for us to share best practices sometimes. So I'm thankful that we can have this this dialogue, this conversation together. So a couple years ago, we were really fortunate. There's a publication in the United States called CINM. Stands for Cabling Installation and Maintenance Magazine. And they wrote an article about using this solution inside of a colo data center, and they were able to work with the colo owner and publish some information. So for those of us that are in the space, we're very familiar that there's not a lot of always best practices shared, because everyone has their own kind of secret way or proprietary way of their doing things. So this is a really good published article, and I'm happy to share the link with you. If you want to send me an email at the end, I can send you the full article. Couple other new things. We're almost done, and then we can take some questions are, again, part of doing these webinars is kind of learning like what's new, what's happening in the industry. Is I've got some customers that are using adding extra pathway for what I'm going to call either a security or a sensing application. So you can see within this future path product, I've actually have a small microduct embedded in there. So this is a 5 by 3.5 millimeter. So it's a really small microduct, like smaller than a straw, right? 3.5 millimeter ID, but there's multiple like 2 millimeter size cables on the market. But what customers are using with this small microduct and these low count cables are, a lot of them are looking into using um, DAS technology, right? So if you're not familiar with this technology, it's incredible, and maybe we could set up a future webinar. But they're on multiple manufacturers basically have these interrogators which can measure like vibration and strain and things like that on a fiber network. So how this is used in a data center network is they put this interrogator on the end of a piece of fiber cable, and it basically sends a pulsing signal down it, and any disruption to the signal, the light reflects back to the interrogator, and it can interpret what is going on. So it's like incredible. So if I had one of these interrogators hooked up to a piece of fiber cable around my data center, and somebody jumps the fence and they're walking on the ground, the interrogator can tell by the vibration that it's a human walking. If I had if I was driving around the perimeter in like a truck, it would know that a truck is driving by, or that there's a backhoe nearby. And so over the years, they've interpreted what all these different vibrations mean in the ground, and it's incredible. So we're seeing customers deploy these, it's called like sensing technology, and of course they're incorporating that into one of the single strands of glass and incorporating it into their duct structure. So hopefully, this was beneficial to you and you learned something. So again, we titled it Creating Chaos Indoor, or Create Order Out of Chaos. So again, putting a little bit more thought and planning into our duct system so that we can keep our cables organized is important. And again, as we kind of went over, variety of outside plant and inside plant solutions, and look forward to following any questions that people have. So before I get going, I love talking to customers, right? Like that's why I'm in sales. I love interacting with customers and getting to know them, and of course solving their problems. So this is a really cute picture of a couple of kids talking, through some tin cans and a string. So please reach out to us. So I am of course based in the US. I might not be the best person because I'm not as local, knowing that the region of the world that I'm speaking to today. So I've got my colleagues' contact information. Yogesh, who handles our EMEA region, I believe he's located in Dubai. Again, you can reach out to me. So take a screenshot or write down our emails. They're really simple. They're just our names. So if you'd love to learn more, if you want a sample of material, right? It's like, hey, could I see this EABF cable you're talking about, Clark? I'd love to see something. Or can you send me a cut sheet? Or can you send me that link to the video? By all means, please reach out. Happy to get to know you. And look forward to a continued conversation. So with that, let's do some questions.
Thank you very much, Mr. Clark. I will start with a question from Mr. David. How many microducts are typically dropped off at each customer site?
I'm assuming we're going to talk about kind of that colo data center area. It depends on how much demand or need is in there. We would always have at least one, if not two, spare microducts, right? So if I'm going to drop off one, that's for my first cable today, and I'm always going to want a spare so that I can upgrade either to a higher fiber count or to add more capacity. So it's very typical that we'll always see a lot of times 3 or 4 microducts to a given location. Of course, I don't know how much demand you might need, right? Sometimes you might only need 2, right? If it's an area that you might not have a lot of growth in, but if it's an area where you have a lot of growth, then maybe we're dropping off 7 or 12 of them, right? So it just kind of depends, but we're at least going to need 1 spare, if not 2 spares. Otherwise, the solution's not, really a viable solution.
Okay, so most of the attendees are asking for the presentation. I guess we can share it, Mr. Clark, with them. We can
Yeah,
send the presentation to all the attendees, and also the whole webinar has been recorded, and you will send the link once it's ready to all the attendees. So I believe, Mr. Clark, you answered Mr. Mahbub regarding the fire-rated duct, but for Mr. Yassin, he was asking about the HDPE multi-duct. He said, does that mean that the HDPE mandatory laying by using steel roll?
Maybe I can find the question. Can you answer? Can you tell it to me one more time? I'm just trying to
All
follow
right.
along.
All right. Regarding the HDPE multi-duct, he
Yes.
was asking that is it mandatory that it should be lying by using steel roll?
Yes, so they're going to come on giant steel reels, right? We do can make some products in sticks, right? So as opposed to a giant reel, a giant steel reel, we can supply products in a stick form, but obviously you just have to couple it up. So it is common to get like a 40-foot length, and I know I apologize, I'm speaking American here, not in meters,
No
but it
worries.
is, you can get the materials in sticks, and they would come in bundles. So that is an option. You just have some more coupling to do. But yeah, we traditionally reels, but we can supply sticks.
All right. So another question from Mr. Mahbub that how you are measuring temperature in sensing as he is doing in cable.
Yeah. So when we talk about sensing, it gets pretty complicated, so we'd probably need like another 1 hour session together. So I'm happy if they want to just send me a note, I can send them some information on fiber optic sensing, and it's an incredible technology, whether it's used for like security or like stress on your glass. And so I would probably just recommend they just send me a note, and I can send them some more details, because understanding the details of how the interrogators work and the technology is fairly complicated. So again, I don't want to elude the question, but it would require a long answer.
All right. So, Mr. Muhammad Dasuki, also you can send Mr. Clark an email regarding the fiber sensing. There's another question from Mr. Jared. If one cable reel of 6,912 can be worth up 500K US dollar, how much value would a full truck load with 12 to 16 reels on the trailer can be 1,728 or 3,456 or any other be worth on average per
Oh,
truckload?
yeah. Obviously, a tremendous amount of cost in fiber optic cable. So, I don't sell the 1728s and the 3456s, but you could imagine a reel of even like say 3456. Maybe you've got 5,000 feet to a reel. Again, like you said, maybe 12 to 16 reels, so you got 60,000 feet. Maybe the cables are going for, and anywhere from $20 to $30 a foot. So you can just kind of do the math. So again, whatever you're kind of paying, but it's the likelihood that a customer is going to need a truckload at one time is unlikely, because a lot of times the runs are much shorter, right? The runs between the buildings are only, let's just say 1,000 feet. So, do I really need, 60,000 feet of 3456? Probably not. Are there some hyperscalers here in the US that do put that many cables and buy that much? Yeah, absolutely there are. But I know that's not the norm. But yeah, the higher count cables are expensive. Yeah, you're going to pay, like I said, $20, $30 more a foot, depending on the strength. count.
All right. So for Mr. Mahbub, he is asking about the fire-rated ducts. If you can suggest the standards, if you can suggest so that they can
Yeah.
include in their future offer. Also, they need the technical data sheet of that. So I believe maybe he can contact Mr. Yogesh, or you can
Yep.
elaborate.
Yeah, he should. Yeah, so I'm not as familiar with the worldwide standards, to be honest. I'm more familiar with the U.S. ones. But yes, absolutely, we make fire-rated materials. They're riser or plenum or low smoke zero halogen. So again, I recommend they just reach out to Yogesh, and he'd be much more familiar with the different standards around the world.
Okay. So most of the attendees also they thank you very much, Mr. Clark, for this very informative session. And I'm just waiting for Mr. Jared. He is typing to see if he wants to ask any other thing. Just 1 minute.
Oh yeah, I appreciate everybody listening, and hopefully it was valuable, and you're able to, maybe learn something. I know a lot of the presentations are, highly technical, and not to say that conduit isn't technical, because there's a lot of variations, but yeah, just understanding different ways to use conduit to organize and how it's used in a data center is definitely getting more popular, at least here in the U.S.
So Mr. Jared is thanking you, and he said, "Yeah, I do transport these cable reels within the US, and I'm only learning more about the value." Thank you, Mr. Jared, for your also your comment. Um, I believe some other attendees are still typing. I don't know. Do you have a couple of minutes or more, Mr.
Yeah,
Clark?
yeah, of course.
Um,
Yeah, as you know, it's early
Great.
here in the morning here in the U.S., so
Yeah.
I'm not rushed to anything. And again, if you're looking for just links to the video that we weren't able to play, or a more specific, obviously, presentation on the enterprise or that EABF solution, we obviously have those. This is just a good overview of a lot of different kind of data center applications. So if you're looking for more information, please reach out.
Great. Is your sensing equipment will detect water leakage or
Yes.
cap? Yeah, on
Yeah,
metal pipe.
so yes, they do. So Dura-Line, obviously, you guys know we're a conduit manufacturer. So we don't actually, make the interrogator sensing equipment, but we have partnered up with several of the companies that do. And there's actually a trade organization here in the U.S. Called FOSA. It's FOSA. It stands for Fiber Optic Sensing Association. And you could just look that up on the internet and learn quite a bit. So Dura-Line has works with several worldwide players. One that we've done quite a bit of work with is called OptiSense. They're based out of the UK, and Dura-Line has a strong partnership with OptiSense, and they are the worldwide leader when it comes to this technology. And they have, I believe, the most like pipeline sensing systems, which are most common for leak detection when we talk about pipeline. But like I mentioned, we're seeing this technology that was traditionally used for like leaky gas lines and pipeline, like oil gathering, moving into the data center space. So reach out to me. I can put you in touch with OptiSense, one of our partners in this space, and we could set up another presentation.
Okay, so Mr. Mohib also is any such a project excited? As gas, oil, sulfur is okay.
Again, I know that I'm not an expert in sensing, okay, right? Because I'm an expert at pipe, but I've been involved with a lot of projects with it, and I would just have to defer. Just reach out to me. I'll put you in touch with the guys at OptiSense, who are the worldwide leaders in sensing. They're based out of the UK, and Dura-Line's got a strong partnership with them. But I don't know so much about oil sulfur, but I know they do all kinds of pipeline work, which is different kinds of liquid, whether it's oil or crude, or gasoline, refined or unrefined. And so I'm pretty confident that they can detect pretty much about anything nowadays.
Great. So,
because these interrogators are incredible.
yeah. So, Mr. Mahbub, it's better to call Mr. Yogesh. He will answer all your questions. And at the end, I can only thank Mr. Clark for this informative webinar and for his time. And we hope all the attendees enjoyed it and learned as much as I did today. Looking forward to welcoming you all to our next webinar. We will announce all the details soon. Thank you very much, and Ramadan Mubarak for all of you in advance. Thank you very much, Mr. Clark.
Yeah, thank you.
Thank you.